Hey guys, welcome back to another video. In this video, we're going to solve a few complex number questions. There are about 20 questions and I'll divide them into about 2 videos. So let's start off with the first question. What does it say? On an Argand diagram, shape the region whose points represent complex numbers z satisfying the inequalities of argument of z minus 1 minus 2i between the angles of minus pi by 3 and positive pi by 3. Great. So let's tackle this step by step. The first thing is argument of z minus 1 minus 2i. What does this mean exactly? Now, you know that this z is a complex number. You don't know which complex number z is. You're not aware about that. But they've also given you another complex number, which is minus 1 minus 2i. But the point over here is whenever they include two complex numbers inside an argument, they're telling you it is argument of z minus z1. This is actually what they are trying to represent. What does argument z minus z1 mean? If we try to represent this according to this, we get argument of z minus 1 plus 2i, where z is an unknown complex number. Great. And this 1 plus 2i is a known complex number, where the complex number is 1 plus 2i. We can represent this as z1, which we know. Argument of z minus z1. I'm doing all this not to solve the sum, but to explain what argument of z minus z1 means. You can skip this part and go to the solving part. But yeah, so we can represent this as this. Great. So what does z minus z1 mean? Z minus z1 is basically, if you draw an Argand diagram is nothing but a graph where you're plotting imaginary numbers against real numbers. They've just given this name to distinguish this separate type of graph where the y-axis is imaginary number and the x-axis is a real number. Great. So if I say z1 is a point over here and z is a point over here, where both of these points are complex numbers. So they have a real coordinate on the x-axis and they have an imaginary coordinate on the y-axis. So for this, let's say this is z1 and this is z. Both of these are complex numbers. What does argument of z minus z1 mean? This means that if you join these 2 points, right, what is the angle that after joining these 2 points you get? Argument. What is the meaning of argument? Argument is basically the theta. What does argument mean? Why do they call it argument? So try to think of this in this way, that they're trying to say that z, a point, a complex number we don't know, is at a position on this Argand diagram which is arguing that it is, let's say this theta is pi by 3. So this is telling you that this complex number z, which is unknown to us, is arguing that it is at a position of pi by 3 degrees of z1. So if z would be over here, it would be like this. Yeah, if z would be over here, let's say z is over here, the argument would be pi minus negative pi minus pi by 3. Why? Because this theta since it's on the negative axis, the theta is negative. Minus pi by 3. So you're subtracting theta from 180 and adding a minus sign in front of the entire theta to get the argument. Why? Because they call it argument to distinguish and tell you at what position this complex number could be in. They're just trying to define the theta at which, or the angle at which, this complex number could be in. So if we know that, if we understand the terminology of writing this thing, we can now attempt the sum. So what do we know from all this? That if they write argument of z minus z1, where z1 is known, we know 1 plus 2i, known, they're trying to define by this expression that it is going to be, z is going to be at a certain degree from z1, and they've told you between what degrees z could be in. This limit of minus pi by 3 and pi by 3 is telling you that z will be at any position which makes an angle, or which is within the angle of positive pi by 3 or negative pi by 3 from this complex number. Z can be any complex number between the range of this degree and negative this degree and this degree with respect to this coordinate. So if we understand the theory of this, we can now attempt this sum. Great. If we try and do that, right. So we know this is a complex number, right? This is, unknown. We don't know what z is. We know z1, calling it z1. We know it is 1 plus 2i. So on an Argand diagram, simply plot the complex number that is known to you. Great. So if you plot that, this is I and this is real. 1, 2, 3. The real part is 1. Great. 1. The imaginary part is 2. Great. Plot it. So it is at a position of 1 and 2. Phenomenal. Now what do you do? Now they're telling you that z is going to be at a point between pi by 3. So you take your protractor, and draw pi by 3 from this point. From this point, you draw pi by 3 and you draw minus pi by 3. Draw what? Minus pi by 3. This is minus pi by 3. So they're telling you, they are trying to tell you that the difference between z and this known complex number will be anywhere between this area, which can go up till infinity, but they've also given another limit. So we're going to consider that as well. But up till now, if we forget this part, what are they telling us? They're telling me that the argument between z and this known complex number is going to be between this range where it goes from positive pi by 3 to negative pi by 3. This means that z, an unknown complex number, can lie on this point, on this line, or in between, anywhere. They've just given you a limit where z can lie, or the unknown complex number can lie. That is also why they tell you on an Argand diagram, shade the region whose points represent the complex number z. So z can be anywhere in here. So if you do understand that, let's consider the next limit, which is real number is less than most likely 3. Right. So they're telling you real number or the real part of the complex value of z is going to be less than 3. So what does this mean? A complex number z can be represented by x plus iy, or if you learn it by a plus bi, whatever you learn it by, x or a is the real part of the complex number. So they're telling you that the real part of the complex number, meaning real part of the complex number z, is always less than 3. So what do you do then? You draw a line at 3. And since they're telling you less than 3, you shade the region. This is your shaded area. Why? Because first condition was z will lie in a range between pi by 3 and negative pi by 3 from the point 1 and 2 I. From this point. Oh my god. Right. From this point. Great. The next condition was the real part of z will always be less than 3. So we draw a line and say that the real part is always less than 3. So what part do we shade? The middle part. Great. So z can lie anywhere over here. Great. Next, b. This was a. They just asked you to draw the Argand diagram, I guess. Yeah. Next is b. What are they telling you? Calculate the least value of argument z for points in the region from A. Give your answer in radians correct to 3 decimal places. So they're telling you that z can lie, for one thing, z can lie anywhere in this shaded region. It can lie on this line, it can lie in between, it can lie anywhere within this triangle. Now, they're telling you, when is the argument z the least? When they tell you argument z, they're trying to know from origin to the complex number, where is it the least? Oh, by the way, my drawing is a bit off. It's supposed to be longer. It's supposed to be a bit longer, sorry. So it's supposed to be around it's supposed to be like this. Great. So they're asking you, when is the argument z, meaning the theta between origin and the complex number z, the least? So where is it the least on this diagram? If you draw a line from here to, let's say, over here, is the argument the least? You could argue, since the value is approaching 0, this theta is approaching 0 as you go lower and lower, you could say somewhere around there the value of arg z is going to be least. But no, you're wrong. Why? Because arg of z can be negative. When is it negative? When is it negative? In this part and in this quadrant. So there is a point over here which will give you the least argument. The least argument. Great. So this is the theta. This is the least value of argument z, since the value is going to be negative. Right. So how do you find this theta? It's simple. Basically, what do you know? You can find out this part, right? Or this part. So let's find out for this part, where the theta is pi by 3. Theta is pi by 3, right? Theta is pi by 3. If I draw this diagram again, this part only, this part, right? So this is pi by 3, where I know this part, this length I know. Why? It is from 1, this is 1, and this is most likely 3, right? Yeah, this is 3. So from 1 to 3, the distance is 2. So I know the adjacent. Do I know the opposite? No. This is what we are going to find out. The opposite side. Great. So what can we use? We can use tan. We can use tan. Tan pi by 3 is up by adjacent, which is 2. So if we calculate tan pi by 3, remember, put your calculator in radians. So op is going to be 2 root 3. Great. So this is 2 root 3. This part is 2 root 3. Great. So if you know that, you have to find out this part, because you need to find out this theta, and you know this length, which is 3, right? So you need to find out this part. How do you do that? Easy. You know the entire part, which is what? 2 root 3. You know this part, which is this part, which is 2. So you subtract 2 from 2 root 3 and get this. So let's call this x. So x is equals to 2 root 3 minus 2. X is equals to what? 2 root 3 minus 2. So now you can find out theta. How do you do that? You use tan again. Tan of theta is equals to oppo, which is x, which is, we just find out 2 root 3 minus 2, divided by the adjacent, which is 3. Great. So tan inverse of 2 root 3 minus 2 by 3, and you get a value of 0.454. Theta is, the argument is 0.454. Great. So do you keep it as it is? No, you don't. Why? Because it's in the fourth quadrant. In fourth quadrant, the argument is always negative, right? So argument is always negative. Therefore, arg of z is going to be minus 0.454. This is your answer. This is question 1. Done. Okay, so let's move on to the next question, which is 2. Okay, so for 2, they've given you a polynomial, which is the function has power of 3. Great. So x cubed plus 5x squared plus 31x plus 75 is denoted by p as a function of x. Great. So A, they're asking you, show that x plus 3 is a factor of p of x. This is very easy. There are 2 ways to do this. One, you put in the value of 3 instead of x. So you're basically putting in minus 3. X plus 3 is the factor. So x plus 3 is equals to 0. X is minus 3. You know the value of x. You plug in the value of x over here, and you will get 0 as the answer. And so you can prove it that way. The other way to prove it is using long division. How do you do that? I'll show it. Long division is actually the better thing to do over here. Why? because in the next question this is going to help you. Great. Right, so if we do the long division, which is going to be x plus 3, you divide x cubed plus 5 x squared plus 31x plus 75. If you do that, you can take a value of x squared, x cubed plus 3x squared, subtract, get 2x squared. Great. Drop down 31x. After dropping down 31x, what can you multiply? You can multiply a value of plus 2x. So 2x squared, 6x. Great. So subtract, and you get a value of 25x plus 75. What can you do now? You can multiply with a value of 25 plus 25. Great. So yeah. So now what can you do? You have used a value of 25, so 25x plus 75, subtract, you get a value of 0 as the remainder. Therefore, prove, this is the proof that x plus 3 is a factor since the remainder is 0. Great. So if that's the case, you can say shown. So the factors are x plus 3 and x squared plus 2x plus 25. Great. This is A. Next part. All right. What is B? What is B? Okay, C is a big question. Anyways, B. What is B? Show that Z is minus 1 plus 2 root 6i is a root of P of Z. Great. So, they're telling you that if you represent this function with respect to Z now, not X, that will have Z, that will have a root Z which is equals to minus 1 plus 2 root 6i. What does this mean? So let's rewrite the equation first. If you rewrite the equation, you're going to get Z cubed plus 5Z squared plus 31Z plus 75. This is the new equation because they are telling you P in respect with respect to Z. So if that's the case, now you know one of the root of this function already, which is x plus 3. So one of the root is, sorry, one of the factor is Z plus 3. This is one of the factor. Now they've also given you another factor. What is the other factor? They've given you the other factor to be minus 1 plus 2 root 6i. Another factor is Z plus 2 root 6. This is another factor. Why have I taken the value of minus in front? Why is this? Why? Because this is the root, not the factor. When you, so Z is equals to minus 1 plus 2 root 6i. This is the root of, this is the root of Z. So when you take this to the other side and make this a factor, the sign changes. So you're basically taking, so this basically becomes this. So since this is the factor, I've put in a minus in front of the entire complex number. That is why the minus exists. So the same thing, you know, if there is a complex number as the root, it will have two complex number. It comes in pairs, right? It will come in pairs. So it's basically a conjugate. What does conjugate mean? If one is plus, the other is negative. In chemistry, you probably have heard about conjugate acid and base. The concept is sort of similar. Over here, the complex number is coming as a conjugate pair. If one is negative, the other is positive. So if that's the case, you can say the other complex number is going to be, the other factor is going to be Z minus minus 1 stays as it is, this sign changes. Minus 2 root 6i. Great. This is now the new equation. This is now the factors of this equation. At least this is what they've told you. Since they've given you one of the root is this, you can deduce that the other two roots, this was from before, from question A, part A, this is from part B, and this is a result of part B. Since they have told you one of the root is minus 1 plus 2 root 6i, the other must be minus 1 minus 2 root 6i. So if you know that, if you multiply all of this, you're supposed to get this function, or this. You're supposed to get it. So what is the simpler way to do it? Remember I told you doing this long division is going to help. It is. So basically, you know x plus 3 is a factor. You know x plus 3 is a, z plus 3 is a factor. So remove this. Forget about this. The one you're supposed to prove is that z should be, the complex number z should be minus 1 plus 2 root 6i. So if that's the case, you should be able to multiply both of these, since both of these factors, let's say, if you multiply both of these factors, you're supposed to get this. Why? Because you're excluding the factor z plus 3 over here, and you're excluding the factor x plus 3 over here as well. So this part, this entire equation should equal to the equation when you multiply both of these factors, and that is going to be the case. So if we try that, z plus 1 minus 2 root 6i times z plus 1 plus 2 root 6i, right? So you can, what can you do? This is, you can say this is A, this entire part is A, this entire part is A, this part is B, this part is B. If you do that, you can use the formula a square minus b square is equals to a plus b times a minus b. A minus b, a plus b. So you can apply the formula a square minus b square. So if you do that, z plus 1 whole square minus 2 root 6i whole square. If you do that, what do you get? Z square plus 2z plus 1 so I square is basically minus 1. So z square plus 2z plus 25. Is this the same as this? Yes, this is. So if this is the case, you have shown. Great. So now is the stinky part. See, this is insanely long, unnecessarily long. Basically they're telling you find the complex number z which are roots of p of z square. I'll try and explain the concept of it, and I'll try to do it quickly. So basically they're telling you that up till now p was a function of either x, where you represent the equation by x, or p was a function of z, where you represent the equation with respect to z and it becomes this. Now they're telling you something different. So now they're telling you that you have to write this equation with respect to z square, not z, not x. So if we do that, if we try to satisfy that, you can say if you make, yeah, great. So if you try to satisfy the equation, condition, you have to put in z square to the power of 3 plus 5 z square to the power of 2 plus 31 z square plus 75. So what is the question? Hence find the complex numbers which are complex numbers z which are the roots of p of z square. So let's go step by step. First of all, I'm asking you, what are the roots of z square? What are the roots? What is it? So z square is going to equal to all of these roots. That was already given in the previous equation, or the previous question, sorry. So they've already told you the roots of x. They've already told you the roots of z. They've basically told you the roots of z square as well. They haven't told you the roots of z. That is what we are going to find out. But if you take z square, let z square be a, you already know the roots of a, because they have told you x minus 3 is going to be a factor, root, minus 1 plus 2 root 6i is going to be a root, and minus 1 minus 2 root 6i is going to be a root as well. So they've told you the roots already. So those roots are going to be the same in this case. However, there is a power, so you have to calculate for that as well, and that's a pretty long process, and we're going to do that eventually. So for now, you know z square can be minus 3, z square can be, what can it be, minus 1 plus 2 root 6i, minus 1 plus 2 root 6i. Z square can also be minus 1 minus 2 root 6i. These are the three roots of z square, not z. Don't confuse it. Alright. So we have to calculate for all of these and get the roots for z. How do we do that? So make z the subject and you take a root of minus 3. How do you solve this? You say 3 times minus 1. Now you say z is equals to root 3 times an imaginary number y, since root of minus 1 is I. Great. Therefore, there is going to be a plus minus since you've taken a root. So plus minus root 3i are two values of z. So you can say z1 is plus root 3i, z2 is minus root 3i. There's basically going to be 6 values of z. So next, what do? You solve for this. What is it going to be? I would suggest not to take a root because you can't solve that exactly. What can you do? The thing that you can do is, you know z is a complex number, right? Z is always a complex number. So if that is the case, in this case, you can represent z as x plus yi and then use identities to solve. X plus yi whole square minus 1 plus 2 root 6i. Keep this part as it is. We're going to touch it later on. Okay. So now you expand this and get x square plus 2xyi minus y square. Y minus, because I squared is minus 1. Why? Because minus 1, root of minus 1 is imaginary, right? IOT. Okay. So if you take square on either side, it becomes I square. I square is equals to minus 1, right? So that is why minus y square. because I is getting squared, so minus y square. Great. So this is equals to minus 1 plus 2 root 6i. What do you do next? You put the real numbers together and imaginary numbers together. So x square minus y square, both of these are real. What is imaginary, or what is the imaginary part? The coefficient in front of I. So you can write plus 2xyi is equals to minus 1 plus 2 root 6i. Now compare. This equals to minus 1 and this equals to this. You're basically comparing coefficients. So you can say x square minus y square is equals to minus 1. What is the other thing you can say? 2xy is equals to 2 root 6. You can say xy is equals to root 6. You can say y is equals to root 6 by x. This is 1. Now you can substitute over here the value of the expression for y into this equation. Great. So if you do that, x square minus root 6 by x whole square is equals to minus 1. Now what do? You expand. X square minus 6 by x square is equals to minus 1. This is the equation that you get. Now the point is, how do you solve this weird equation? You can say let x square be a. If that is the case, you can say a square plus a minus 6 is 0. Solve for a and you will get most likely so you will get x square, sorry, is 2, a is minus 3. These are the two you will get. So if that is the case, you can say x square is 2 and x square is minus 3. Now this is not applicable. Why? Because if you take the root, x is equals to root of minus 3, this becomes imaginary. Now why can this not be imaginary? Because I've already told you that x, if I write x plus yi, both x and y are real values. The only imaginary part in this expression is I. Only I is imaginary. Except for that, both x and y are real. Both of these values are real actually. But what is the imaginary part? I. And y is the coefficient of the imaginary part. Y is itself not an imaginary part or an imaginary expression. I is imaginary, right? So x cannot be imaginary. It has to be real. So x is plus minus 2. What do you do next? You take this and plug it over here and get the value of y. So x is root 6 by plus minus 2. So if you plug that in, you get, alright, I forgot to add the root. Right, so if you add this, you're going to get root 3. Great, so you're going to get plus minus root 3. So this is the value of y. Okay, so you can now say that z can be, z3 is, so another thing to note is if x is positive, y will also be positive since there is no negative sign over here. So if we are taking positive root 2, we are getting positive root 3. If we are taking negative root 2, we are getting negative root 3. Great. So if that's the case, we can say root 2 minus root 3 I believe that's the answer. Right, positive root 3i. Okay, so if I take the other value of x, which is minus root 2, we are going to get minus root 2 minus root 3i. So you've gotten 2 to 4 values for z. Okay, so the rest of the two are going to be, so this is going to be pretty much the same thing. However, in this case you're taking minus over here. So I would suggest not doing the entire thing again, since you already know what's going to change. What is basically going to change is, I'll still show it. You can skip to the end. So basically you're going to get, see, there was a positive over here and there's going to be a negative over here. So when you equate, you're going to get this remains same. Because is there a change between this part and this part? No, there is no change. There is no change. Where is the change? Over here and over here. Since there is a minus in front of 2 root 6i. Therefore, we're only going to deal with that part. You all, this entire part is going to remain the same since the values of x are not changed. So, values of x are going to remain plus minus root 2. Great. So values of y is going to be changing. Why? Because let's say for 2xy is going to be negative 2 root 6i. Sorry, just 6 root 6. So y is minus root 6 by x. So when you plug in a positive root 2, you're getting a y is equals to minus root 6 by positive root 2 is going to give you a negative root 3. So over here is going to be minus plus root 3. Why? Because when you're plugging in positive root 2, you're getting a negative value, and when you're plugging in minus root 2, you're getting a positive value. So in this case, for z5, it's going to be positive root 2 minus root 3 I, and z6 is going to be positive root 2, sorry, negative root 2 positive root 3 I. Okay, that was it for question 2, which was exceptionally lengthy. We can move on to the next question. Alright, question 3. So they're telling you on an Argand diagram, sketch the locus of points representing complex numbers z satisfying z plus 3 minus 2i is equals to 2. Alright, so what does locus of points mean? A lot of people have this misconception in complex number that locus means a circle. No, locus does not mean a circle. Yes, when you plot the points, you get a circle. But locus itself does not mean a circle. Rather, even this equation is not exactly telling you that it's a circle. This is not a circle equation exactly. From this, you will get a circle equation, definitely. The proof is over here. If you want to look at the proof, you can. So this is the proof. I'm not going to go over the proof. You can read it on your own and see that why you get a circle whenever there's an equation like this. But the point is, this is not a circle equation exactly. And locus does not mean exactly a circle. What does it mean? So basically, what this equation, let's try and understand what this equation means. They're telling you, if I represent this as a complex number, I have to write it as, first of all, I take minus common because they're trying to find the difference between two complex numbers. There's no point in adding two complex numbers. They're always trying to find the difference either in distance, either in position, or anything, or theta. It can be anything. So they're always trying to find the difference in any metric between two complex numbers. So you take the minus common and say it is minus 3 plus 2i, right, is equals to 2. So you can represent this as z1 just for the sake of understanding. So you can say this is z1. Great. So if that is z1, you can say that z minus z1 is equals to 2. What on earth does this mean? Modulus means distance or the magnitude. So the magnitude or the distance between the complex number z that is not known to us and the known complex number is always going to be 2. So which point is known? Z1, which is -3, +2, -3, +2, and we've plotted that. Now the question is, where is z? You don't know that. You don't know that. So they've also given you another condition, that the difference between the complex number z and z1 will always give you 2. So z can be over here, over here, over here, over here, over here, over here, or over here, anywhere on this circle. So when you plot those points of z where z could be, then you get a circle. So locus is basically an arc, a shape, anything, any sort of shape that you get when you join a number or a series of points. A locus can be an arc, a circle, anything. It's the shape that you get when you're joining those points. Locus itself is not exactly a circle, right? Since you start off with these examples, you get that concept of locus is a circle. But that is not exactly the point. The point is, when you try to make sense of this equation, you understand that the z in the complex number z is in such a position on this Argand diagram where y is the imaginary axis and x is the real axis. Z will always be in such a position that it creates a distance of 2 between this defined complex number, which is known to us, and this unknown z complex number. So z has to be on this very circle, or else if it is, let's say, even over here, this doesn't make a distance of 2, which is why z has to be anywhere on this circle. That is why they're giving you this equation. That is the point of this equation. So that was basically making sense of the equation. Now what do we do? Now let's try and solve this. So you know that z plus 3 minus 2i, they're giving you the modulus. If you make this the subject, take the minus out, you get the complex number z1 and you plot that point, which is this. Great. So now you draw a circle, since you know the distance between z and z1 is always going to be 2. So this is going to be a circle with center -3 and 2 with radius of 2. And the proof of getting this is over here. Great. So center -3, +2, radius 2. Great. So you've drawn a circle and you've done A, part A. That is basically the point of A. Now what is B telling you? B is telling you that find the least value of mod z for points on this locus, giving your answer in an exact form. Mod z. What does mod z mean? Mod z is basically the distance of complex number to origin. So mod z, let's say there was no question A. Forget question A. And they're telling you find mod z, or they're asking you what is mod z. Mod z is basically, z can be anywhere on this Argand diagram. You don't know that. But mod z is basically telling you, if let's say the complex number was over here, mod z is telling you what is the difference or the distance between this point and origin. That is modulus z. So z can be represented by x plus yi. So you take, let's say z is 3 and y is 2, assuming. So this is 3 and 2, right? So this is the point where this distance is 2, this distance is 3. So you draw a line to this point and you find the hypotenuse. Why? You're trying to find the modulus or the shortest distance, the magnitude. So what do? Pythagoras theorem, r square is equals to 2 square plus 3 square. R is root over 2 square plus 3 square, and you get the modulus or the modulus z, meaning the distance between the complex number and origin. Great. So they're asking you the modulus z for points on this locus. On this locus, what does this mean? On this locus means the z lies on this circle, anywhere on this circle. So they're trying to find out the least value of z. Least value of distance between z and origin. So where is the least value? Is the least value going to be over here? Over here? No. Why? Because from this point to this point the distance is 3. However, if you draw a tangent and draw from over here to over here, you see this is actually the least point, or the point where the distance is least to the origin. And this is almost always going to be the case. If the circle was over here, the least would be draw a tangent. Draw a tangent, right? And next, what do? Next, from the center to over here, draw another line. You know this point is the point which makes the least distance from origin. This is always going to be the case, right? So if you know that, let's attempt. You need to find out mod z, meaning the least distance. So they don't want to find the complex number itself, they want to find the distance only. So if that's the case, you know the radius is 3. You know the radius is 2. So the first thing you can do is find OC. OC. How do you do that? Simple equation, the distance equation. From 0 minus 2 whole square, 2 whole square, 0 minus 3, 0 minus 3 whole square. So you get root 13. This is the value of this entire length. Now you also know the radius, so you subtract the radius and get OD, which is the least distance. OD is root 13 minus 2. Great. So that is answering 3B.